Welcome to Quarantine Vlog Day 3. It's Thursday. I got a short day today. I've only got a couple hours to be here. So, take it off from yesterday. I made the program tweaks that I gotta make. So I'm gonna load that up and make some parts. Yes, should work. Let's go do this. So yesterday I was inspired. So in the first video, in the machine, I have 3 coolant lines and they're tight. They have to go in a tight little area. And what I ended up doing is I bunched them into a triangle like that, and then I zip tied them together. Except even that is crunching between 2 rigid objects during a full movement one way. And I can hear it crunching. I think it's like barely fine, but I can tell they're doing that. So bunched into a line didn't work. So I tested and I took a zip tie and I threaded it between them and around like figure 8 style to keep them flat. And that worked pretty good. So I was like, let's do this. Check this out. So I 3D printed a kind of clamshell design that's meant to use 2 zip ties. I've just got one on there right now, to kind of cinch them together. And they turned out so good. So 2 clamshells. I've got little locating notches. This one's got the negative. The other side has the positive. So I brought it home where my 3D printer is, and I printed a bunch of them. Break it off the raft right there. So the little locating notches. One's got a male, one's got a female, and they locate together. Quick design, quick print, perfect first try. So on the lines, I'm going to do, however many I need to keep them nice. Very happy about that. Look at that. That looks so good now. Yeah. Those turned out great. I've made my first part, finally. Making good progress. It's close. I had to do a ton of tweaking, especially with the holes. And the threads look good. The Higby thread needs work. And it's looking good. It's looking pretty good. I'm not too dissatisfied with that. Right now, let me show you. Right now, I'm dealing with this guy. Ejector alarm. So remember yesterday when we made the emergency collet here, which is, it's usually got a tiny hole through the middle. We bored out the inside, except this is the pusher ejector rod. So it's got an air cylinder right there that, once that pressurizes, then the ejector goes forward and spits the part out. There's a long rod that goes in here, and you can usually see the ejector rod come out the side. This is not bored all the way through because I only had to bore this deep. So let's pull that out. All right, as you can see, that hole does not go all the way through. So the hole is about that deep and I've got about that much left to go. I got to figure out a way to get through that. I don't know if my boring bar is actually long enough to get in there. So check this out. There's the ejector sticking out. If I move, this is the rod. If I move it in and out, that's what happens. So the collet is told to open up, and then it's free floating part, and then the ejector goes pa-choom, and then it spits it into the chute down here across the carousel, or the conveyor, and then it dumps it into my parts carousel, where I can choose how many parts per bin. This thing works awesome. We got a video on that. Check it out if you haven't seen it. Yeah, so because the part is a thin wall part with a hole in the middle, I can't use anything smaller than that, and I can't use anything bigger than that. This is a 300 diameter pusher, and then the part is 305-ish. So I gotta make that work, which means I gotta make that hole bigger. I think I have a plan. I don't have a drill bit the right size to like accurately do that, a 300, 305 drill bit, not in carbide, and I don't want to mess up the front bore. So what I have is a thread mill. This is a 300 diameter thread mill, and I think what I'm going to do is I'm going to spin this as a live tool. Actually, if I mount it rigid, I could probably keep it stationary and pretend it's a boring bar, but I think I'm going to spin it in one of the live tools. I'm going to go in the center, and I'm going to slowly just plunge the rest of that, probably on center, through it. Spin this, keep it on center, push it through, see what size hole that makes me, and then if I have to, I can offset it and do the same thing again, really, really slow, and make the hole just a little bit bigger. I think that'll work. I have 45 minutes before I gotta go. Yeah, I wanna make a part. All right, here we go. Thread mill drilling into the collet. It's gonna be cool because through coolant's gonna come through. Here we go. Let's try 300. $300 fits. Let's try 301. $301 fits. It is bottoming out, probably on the ejector. I'm not positive yet. Let's find out. Yeah, definitely on the ejector, so that's okay. 302. Not really. So the ejector is sticking a little bit. There's a lot of length in there, and it's definitely not dead center straight. So it's sticking a little bit. It means I got to go a little bit bigger. Bummer. So I'm just going to offset the tool a little bit, run the same program again. Should be fine. All right, guys, that's it for me today. I've made my second part. It's functionally good. Tolerance is a little bit out, so I'm done for the day. But tomorrow I'm going to do some minor fine-tuning. The fact that we have a good part coming off is huge, huge win. It means that the whole system works. The machine is dialed. Everything is good. So... oh yeah. So tomorrow, dial it in brass and then switch to stainless. Maybe I'll go over the part, the tools a little bit more, and I want to show a whole cycle in brass so that you guys can actually see what's going on. So I'll see you guys tomorrow. Thanks. Bye.